This was a test on triangle centers and quadrilaterals, and I'm just going to roll through it right now. Match the type of line with its point of concurrency. Let's see, so medians, that goes with centroid. Altitude, that's orthocenter. Angle bisectors, that's incenter. And perpendicular bisectors, that is circumcenter. So that was just straight memorization. All about those flashcards. Hope you studied them. Okay, your town is holding local elections. The town sets up 3 polling stations around the area that form a triangle. They decide to meet at the in-center of their locations. The in-center is equidistant from the 3 sides of the triangle formed by the polling stations. Alright, well that's a lot of words just to be saying sides. But yes, the in-center, yeah, that's the main property of in-center, is that it is equidistant from the sides of a triangle. So hopefully you put D for number 2. Circumcenter. Okay, as soon as I see the words circumcenter, I'm thinking 2 things. I'm thinking that the circumcenter is equidistant from the vertices. And I'm also thinking that circumcenter is made up of perpendicular bisectors. Okay, first of all, let's deal with the equidistant from the vertices part. Equidistant from the vertices means, alright, if this is the circumcenter, then this distance and this distance and this distance will all be the same. Okay, so because this is the circumcenter, everything that I just marked in red, those distances will all be equal, so keep that in mind. Now, let's see what else we've got. OS is 14. Okay, so we're given that OS is 14. And OR is 20. Okay, OR is 20. So this is 20. And PQ is 32. Okay, so PQ is this right here, and that is going to be 32. Alrighty then, so given that information, we're supposed to find these 4 lengths. OP. Let's see, OP is from here to here. Well, if this is 14, then this is 14, so this OP has got to be 28. So that's going to be 28. Let's see, what's next? What's next? OR. Wait, no. OR. Oh, QR. They gave us QR was 20. Well, you know what? That's weird because it turned out to be the same thing, but anyway, they gave us a QR was 20. I read that as an O. QR was 20, so they were giving us this right here. They gave us a QR was 20, which means that OR is also 20 because it's one of these 3 red lines. that we said would all be the same. So all three of these red lines are going to be 20 because QR is 20. So OR is 20. RP. RP is the other red line, so that is also going to be 20. And TP. Okay, well, that's just this one. TP is half of this 32, so that's going to be 16. Okay, so TP is going to be 16. We didn't even have to do the Pythagorean Theorem. I was all ready. I was ready to do the Pythagorean Theorem to find SR or UR or TR or something. But they didn't ask us for those, so we got off easy. Okay, moving on. Look at number 4. Centroid. Centroid is the one where it's all about the thirds. Okay? And it's made up of medians, but centroid is the one where the median, these are all medians, and they're going to be divided up into a big part and a small part, where the big part is always twice as big as the small part, and the big part is 2/3 of the whole thing, and the small part is 1/3 of the whole thing. So this is the one where we get to split everything up into 3 equal parts and all that. Also, please remember that centroid is a bunch of medians. Okay, which means that E and all these other points that touch the sides are midpoints. They're all midpoints. Anyways, let's see what we're given. DE is 15. Let's mark that. So DE is 15. So this little distance right here is 15. You know, I feel like I need to make this bigger. Okay, so DE right here is 15. So this is 15 right there. We're supposed to find CD and CE. Well, that is going to be a piece of cake, because this is the one where we do the 3 equal parts and all that good stuff. So and another way to look at it is the big part is always double the small part. Sometimes I like to say, well, if this piece is 15, then we have 3 of those, so this will be 15 and 15. But however you look at it, this piece right here is going to be 30. You can look at it as being double the 15 if you want. But so CD is definitely 30. And CE is going to be 45. You know, 30 plus 15, or 15 plus 15 plus 15. CE is going to be 45 because that's the whole thing. Was that it? 30 and 45. Well, that was not very tough. Almost not even worth zooming in for. Okay, that was number 4, by the way. Okay. Number 5. X is the in-center of the triangle. Find XU. In-center, hey. Because it's the in-center, that means it is equidistant to the sides. Equidistant to the sides. Okay, that is the special property of the in-center. So that means the following 3 lengths are all equal. Alright, these 3 lengths are the distances to the sides. And we are supposed to find XU. Well, we are not given any of these 3 lengths, but we can find WX right here. So they're saying find XU. Oh, X is the incenter, but then they have this X like it's a side. Anyway, a little confusing, but we can find the length of this side right here, which I'm going to call B, because that really looks like it's that, but it should be here. But we can find this by the Pythagorean theorem. So we could do it like this, you know, a squared plus b squared equals c squared. Okay, I am doing the Pythagorean theorem on this triangle right here. Bling! So 13 is the hypotenuse, which is how I knew to put it off by itself in the equation. So that's going to make 144 plus b squared is equal to 169. Subtract 144 from both sides. So that's going to leave us with b squared is equal to 25. Take the square root of both sides. And of course that's going to give us b is equal to 5. Okay, so that's WX here is going to be 5. Alright, so this is going to be 5. But that means that all three of these red lengths, including XU, will be 5. So that's why this answer is going to be 5. Okay, a little Pythagorean theorem never hurt anybody. Number 6, consecutive angles in a parallelogram are always supplementary. Yeah, they're always supplementary. So that's C. Just to be clear, when they talk about consecutive angles in a parallelogram, here's a parallelogram. Consecutive angles are like these angles right here would be consecutive. Okay, these would be supplementary. Or these angles right here, these would be supplementary. Or these angles would be supplementary. Or these angles would be supplementary. Those are all examples of consecutive angles. If this one was 80, this one would be 100. Okay, so that's why it's C. Anyways, moving on. Choose the statement that is not always true for any parallelogram. Alright, that means 3 of these statements are going to be always true. So let's look for the ones that are always true and then cross them off the list. We're looking for the one that is not always true. So, let's see. The diagonals bisect each other. That is always true. That is one of the properties of a parallelogram. Opposite angles are congruent. That is always true. Another one of the properties of a parallelogram. The diagonals are perpendicular. That is not always true. That's going to be the answer. The diagonals bisect each other, but they're only going to be congruent. They're only going to be perpendicular if we are talking about a rhombus. That's the only kind of parallelogram with perpendicular diagonals. So let's look at the last one just for fun. Opposite sides are congruent. Yes, that is one of the properties of a parallelogram. So the only one that's not always true is the one about the diagonals being perpendicular. Okay. Look at number 8. Which statement is always true? All quadrilaterals are squares. Yeah, well, that's clearly not always true. Everything is not a square. All rectangles are squares. Let's see. There's a rectangle, but it's not a square. So nope, not all rectangles are not squares. So no. All parallelograms are quadrilaterals. Well, yeah. A quadrilateral is just a four-sided figure. So saying all parallelograms are quadrilaterals is just saying that everything that looks like this, hold on, here's your classic parallelogram. They're just saying every parallelogram has 4 sides. Yeah, that's definitely going to be true. All quadrilaterals are parallelograms. No, that is clearly false. It could be a trapezoid or a kite, or none of the above. So it could be random. Okay, so there you have it. All parallelograms have 4 sides. That is always true. Number 9, choose the statement that is not always true. For an isosceles trapezoid. Okay, well, to answer this correctly, you kind of need to know what an isosceles trapezoid is. So here is an example of an isosceles trapezoid. You're probably used to seeing it this way, so I'm just going to rotate it around for you because I'm a nice guy. Okay, an isosceles trapezoid. This is a trapezoid, obviously, because it has the bases that are parallel. So let's start with that. The definition of a trapezoid is it has a quadrilateral with 1 pair of parallel sides. So, for example, these are parallel sides. They are called the bases. So this is a base and this is a base. The non-parallel sides are called legs. So this is a leg and this is a leg. The thing that makes it isosceles, okay, key word, isosceles, is that the legs should be congruent. So this leg and this leg should be the same length if it's going to be isosceles. Because of the balance, the symmetry, if you will, then that causes things to happen. Like, for example, say if this is 80 degrees, okay, for this angle, then this angle will also be 80 degrees. Base angles of an isosceles triangle. An isosceles trapezoid. Of course, in any trapezoid, these would be supplementary. So this is going to be 100. But guess what? This will also be 100. So this is sort of a nice little picture of what happens in an isosceles trapezoid. Okay. Also, because of that symmetry, though, the diagonals are going to be congruent, just like for a rectangle. So that's a diagonal, and this is a diagonal. Okay. And if this is isosceles, then these diagonals should be congruent to each other. So, now that we got that straight, let's look at the options. So we're looking for the statement that's not always true. The diagonals are congruent. Well, that is always true. If it's isosceles, it has symmetry, the diagonals will always be congruent. So we'll cross that out. We're looking for one that's not always true. The base angles are congruent. Well, that's like I just showed you. That's 80 and 80, for example. Those are base angles. 100 and 100. For isosceles, it has symmetry. The base angles are always congruent. So that's not the answer. The diagonals are perpendicular. Guess what? Ding, ding, ding. That's going to be the answer. The diagonals, as you can see in this example, are not perpendicular, and in general they will not be perpendicular. The legs are congruent. Of course, that's what makes it isosceles, is the legs would be congruent, so that would always be true. But the diagonals do not need to be perpendicular. That's will be true for a rhombus, and it will be true for a kite, but not necessarily for an isosceles trapezoid. Okay. So, C is the answer. Moving on. Number 10. Which type of quadrilateral has no parallel sides? That's a kite. Kite has no parallel sides. Of course, a rectangle and a rhombus are parallelograms. So they have both pairs of opposite sides parallel. A trapezoid as you just saw, by definition, a trapezoid has exactly one pair of parallel sides. So that just leaves a kite. A kite doesn't have any parallel sides. So D. Just to be thorough, this is what a kite looks like. Notice that none of these sides are parallel, just like I said. Anyway, back to the test. Number 11. This parallelogram has angle PML that's 83 degrees. Let's check that out. PML. So that means I got to go from P to M to L. Okay, so there's angle PML that I've just shown here in red. And that red angle is 83 degrees. Maybe I'll go ahead and mark that. Okay, so this whole thing is 83 degrees. Now, we're supposed to find the measure of angle PQL. Okay, well that's kind of easy. PQL goes from P to Q to L. Okay, so that's the angle I just showed here in blue. Well, if this is a parallelogram, then opposite angles are congruent. Yeah, so if this is 83 degrees, then this will also be 83 degrees. So, kabam! PQL is 83 degrees. Come on, give us a challenge. This is nothing. Oh, I was ready to do some work, but it just didn't happen. Okay. We're given some lengths here. We're supposed to find the values of x and y, given that this thing is a parallelogram. Okay, let's see what's what. ON is 7x minus 5. So this is 7x minus 5. LM is 6x plus 3. So LM is 6x plus 3. You know what? I just want to pause right there. I can find x right now, and I bet you can see how I'm going to do it. Opposite sides of a parallelogram are equal. That means these two expressions should be equal. So that means, por ejemplo, 7x minus 5 should equal 6x plus 3. So if we solve this, it's going to look like this. Minus 6x on both sides. So that's going to leave me with x minus 5 is equal to 3. If I add 5 to both sides, then x equals 8. So check it out. X equals 8. Ta-da! We're halfway there. X equals 8. Now let's switch colors for the other part. NM is x minus 4. X minus 4. OL is 2y plus 5. So this is 2y plus 5. Now, I got to tell you, it was kind of funny, but also very sad. During the test, when kids were taking this test, in every class I had maybe 4 kids ask me if there was a mistake in the test. They were saying, didn't you mean for this to be a y, Mr. Burton, or something? Or maybe you meant for this to be an x? I don't know, but you know, clearly these are across from each other, and you'd be expecting this to be the same, so I could make my equation and go to town and find the y. But here's the thing, this is not a problem, and I hope some of the kids figure this out. Yes, we are going to set these equal to each other because they are opposite sides. 2y plus 5 will equal x minus 4. And yeah, you might normally think this would be a problem with having a y and an x unsolvable. Do you see it? Can you see it? Yeah, we just found x like 2 minutes ago. X is 8. So that's not a problem. I will just take x and replace it with 8, and then I am good to go. So this is going to give me 2y plus 5 is equal to 8 minus 4. So 2y plus 5 is equal to 4. And then I go on like normal. Minus 5, minus 5. So that's going to give me 2y is equal to negative 1. Divide by 2 on both sides. And that gives me y equals negative 1/2. Okay, so people were freaking out, man. Like, what? How could you possibly ask us to do this problem when we have a y on one side and x on another? Well, you find x first and then plug it in. So y equals negative 1/2. Okay, I'm hoping you see it now and you're going, oh yeah, that was pretty obvious in retrospect. Hindsight is 20/20. Number 13, find the value of each variable in the parallelogram. Show your work. So here we go, basically the same type of thing. It's a parallelogram, so the diagonals bisect each other. That means this red dot is a midpoint for both diagonals. So, of course, that means, for example, that, let me be consistent. That means 3x plus 2 should equal 23, right? Because this should equal that. So, minus 2 on both sides, so that'll be 3x equals 21. Divide both sides by 3. That's going to give me x equals 7. So x equals 7. Okay, and on the other hand, this part should equal this part. So that means 7y minus 2 is going to equal 5y plus 4. Let's subtract 5y from both sides. That will give me 2y minus 2 equals 4. Adding 2 to both sides, that will give me 2y equals 6. Alright, dividing by 2 on both sides, that's going to give me y equals 3. So y equals 3. I better put a box around that or something. Okay, that is how you do that. Alright, moving on. Number 14. Okay. So I'll find the x's first just because they're alphabetical. Supplementary, my dear Watson. Supplementary. These angles where the x's live are there in these consecutive angles of the parallelogram. So hopefully by now you've mastered the fact that these will be supplementary. So that means that 4x plus 2x should equal 180 degrees. Supplementary, they add up to 180. So that means 6x is going to equal 180. Divide both sides by 6. And voila. There you have it. So x is going to equal 30. Okay? So x is 30. Now for the y's, of course, we're just going to set the y values. We're going to set these expressions equal to each other. They're just plain equal. Opposite sides are equal. So that means 2y plus 3 will equal y plus 9. Subtracting y from both sides is going to leave me with y plus 3 equals 9. Subtract 3 from both sides leaves me with y equals 6. So y is 6. Okay, moving on. Alright, number 15. Isosceles Trapezoid. Well, we should definitely draw that, don't you think? Let's draw this, man. Isosceles Trapezoid. So you know that's going to be a trapezoid of an isosceles nature, like this. I feel like turning it over, but that's just me. So here's our isosceles trapezoid. Just like we talked about previously, if this is isosceles, that means the legs will be congruent. So, isosceles trapezoid JKLM has legs JK and LM. So look, I control where these letters go. But I know that JK is supposed to be a leg. Do you understand what I'm saying? See this side over here that has a little congruent mark on it? This is a leg right here. That's a leg. This is a leg right here. So when I pick my lettering, I need to make sure that JK winds up being a leg and LM winds up being a leg. And KL has to be a base. So just be careful how you letter it. So, let's see. JK is supposed to be a leg. So, how about if I start down here? If I label it like this, JK LM. So, LM. Okay, that would fit with the idea of just going around the clock. JKLM, JKLM. But JK and LM are supposed to be legs. Are they? There's JK, there's LM, they are legs like they're supposed to be. It's supposed to have a base KL. So here I have KL as a base. So that's fine. What I have is fine. Now, the way I drew this, it happens that KL seems to be the smaller base compared to JM. Well, that is random. So, don't get attached to the fact that KL is going to be smaller. If we're going to do what we do, but if somehow we plug the numbers back in and we found out that KL was actually longer than JM, we would not be surprised and we would roll with that. Let's move forward. Okay, let's get rid of that stuff. Anyway, so JK is 8x plus 9. Okay, so this over here is 8x plus 9. Alright, and what else we have? That was JK. KL is 7x plus 10. So this is 7x plus 10. That's a KL. LM is 10x plus 2. So this LM is 10x plus 2. And we're supposed to find x. Well, we're only going to use 2 of these 3 things. And really, I would guess we didn't even really need to draw a picture to be able to do this. But is probably helpful. It's the legs that are going to be congruent. They told us that JK and LM are the legs. So that meant that JK and LM are the things that should be equal to each other, with or without a picture. The legs are congruent in an isosceles trapezoid. So 8x plus 9 must equal 10x plus 2. Plain and simple. So that's all there really is to it. 10x plus 2 must equal 8x plus 9. That's the key. Subtract 8x from both sides. So that's going to give us 2x plus 2 is equal to 9. Subtract 2 from both sides. That's going to give us 2x is equal to 7. Alright, it's not going to be an even number, but I don't think I'm making a mistake. Better double check it though, just to be sure. So that's going to give us x equals 7 over 2. Okay, which as a decimal is 3.5. So that's the answer. X is 7 over 2 or 3.5. Same thing. Okay, number 16, mid-segment. Well, mid-segment is the segment that connects the midpoints of a trapezoid. So, you know, maybe this is about the mid-segment right here, something like that. Anyway, maybe it's a little lower, but it's the average. The mid-segment is the average of the two bases as far as the length of it goes. So, say if I call this mid-segment x, then the average, the x should equal 22 plus 36 divided by 2 should be the mid-segment. It's just the average. (22 plus 36 divided by 2). That's 29. Yeah, so you know, 29. Hey, that's all there was to that. It's just the mid-segment is the average. Number 17. Look, this is a kite. Check it out. Consecutive sides are congruent. It's a kite. That means we have symmetry. So just, I don't know if it's going to come up or not, but just in case it does, please understand that this this line that I'm drawing, let's make it red. That red line I just drew is the line of symmetry. So there's balance above and below this red line. And we're supposed to find the measure of angle t. Okay, the measure of angle r is 130 degrees. So let's go ahead and put that in the picture. Okay, so this angle right here is 130 degrees. The measure of angle s is 60 degrees. Okay, so this angle is 60 degrees. Remember the balance I was talking about above and below the line of symmetry? If this is 60 degrees up here, then this will be 60 degrees down here as well. Okay, I probably should show that second one in red to reflect that we weren't given it, we are surmising it. Okay, we're told angle S is 60, we can conclude that angle U is also 60. And we're supposed to find the measure of angle T, the missing angle right here. So we can just find that by subtracting from 360. Okay, so I'm just going to take 360 degrees and I'm going to subtract 130 and 60 and the other 60 and see what I get. clear this out first. Okay, so I'm going to start with the whole 360 degrees, or that's the total of any quadrilateral interior angles. So, and then I'm going to subtract 130, and I'm going to subtract the 260s. And just see what's left. 110 is what's left. So that is 110 degrees. Okay. Number 18. MNOP is a square. They didn't give us the picture, but they told us it was a square. So, fine, there's a square. MNOP. Fine. Let's see. NO is 3x plus 14. Okay, so this is 3x plus 14. Okay. And OP is 5x minus 8. So this is 5x minus 8. Well, guess what? Since this is a square, then these should all be equal to each other. So 3x plus 14 and 5x minus 8 should be equal. So piece of cake. 5x minus 8 should equal 3x plus 14. Subtract 3x from both sides. That leaves me with 2x minus 8 is equal to 14. Okay. Let's add 8 to both sides. Okay, so that's going to give me 2x equals 22. Just divide both sides by 2, and you get x equals 11. Okay, but guess what? That's not the answer to the question. We're supposed to find the length of MP, so don't just put 11 down for your answer. That's x. MP is the length of one of the sides, but all 4 of the sides are the same. So I'm just going to plug in 11 for x. I really could use either one of these sides because they're all the same, but let's say if I use the 5x minus 8. Okay, so that's going to make this 5 times 11 minus 8. So that's 55 minus 8. So that is 47. So that means PO is 47, which means all of the sides are 47. It's a square. So 47, my friends. That's how you do number 18. Okay, what about number 19? Another square. Well, it's a square. That means that every one of these angles is 90 degrees. Okay, so that means this 3x is equal to 90 degrees. So, pretty simple. 3x is equal to 90 degrees. Divide both sides by 3, and what do you get? X is equal to 30. Alright, so there's that. What's next? Bring it on. Number 20. Rhombus. Talking about a rhombus now. All sides are congruent. The perimeter is 72. Find x. Okay, and they gave us one of the sides. So look, we're talking about a rhombus, okay? Rhombus has all 4 sides equal, so this is my impression of a rhombus. Okay, so they gave us one of the sides is 2x plus 6, but because it's a rhombus, that means all 4 sides are 2x plus 6. So that means this is 2x plus 6. This is 2x plus 6. This side is 2x plus 6. And this side is 2x plus 6. The perimeter is 72. Alright, do you know what perimeter means? Alright, perimeter means adding up all the sides. So that means that if I take 2x plus 6, now the quickest thing to do would be just to do this times 4. But, you know, I'm just going to show it. 2x plus 6 plus 2x plus 6 plus 2x plus 6 plus 2x plus 6. Okay? 1, 2, 3, 4 of these things should all add up to 72. That's what perimeter means. Now again, it would have been easier just to do 4 times 2x plus 6 rather than adding it 4 times, because then I could just do the distributive property. It's just a little quicker. So that would tell me that this is going to be 8x plus 24. Alright, but either way, I'm going to get that 8x plus 24 is equal to 72. Alright, so guess what? We subtract 24 from both sides. So minus 24 minus 24. So that's going to leave me with 8x is equal to 48. So I need to divide both sides by 8. Okay, so that's going to be 6. Alright, so x is equal to 6. So that's why the answer is D for number 20. Okay, let's move on to number 21. Almost done. JKLM is an isosceles trapezoid. This time they went ahead and gave us the picture. Find the missing angles. Well, angle K will definitely be 60 because it's got to match angle L over here. So angle K will be 60. Let's see. Well, these other two will have to be supplementary. Okay, so I'm just talking 180 minus 60 here. So angle J is going to be 120. Okay, so that's going to be 120 degrees. And of course, angle M, same story. So that will also be 120. Okay, that is it for number 21. Number 22. ML is 6 and LN is 8. So ML is 6. Let's put that in there. LN is 8. This is a kite. You can tell because of the consecutive sides that are congruent. In a kite, this is the diagonals are perpendicular. Same with a rhombus. So I know that's going to be a right angle. We're supposed to find MN. This looks like a job for the Pythagorean Theorem. Focus your eyes on this triangle right here. Here to here to here to here. Okay. Let's see, let's make it red. Let's make it a little thicker. Okay, that red triangle is the one on which we are about to work the Pythagorean theorem. 'Cause mn would be the hypotenuse, so be careful where you put it. So leg squared plus leg squared equals hypotenuse squared. So I'm thinking 6 squared plus 8 squared is equal to x squared. So that's going to be 36 plus 64 is equal to x squared. 100 is equal to x squared. Take the square root of both sides, and x is 10. Okay, so that's mn is 10. Alrighty then. Multiple choice review problems. What's up? Oh, okay, yeah, review problems. So here are a few problems from units in the past. Which of the following is true? So I've got only one of these is true. So if I find one that's true, I'm done. The sum of the interior angles of a polygon is 360. If and only if it's a quadrilateral. Yeah, guess what? That's the answer. Okay, quadrilateral is any four-sided shape. And yes, any four-sided shape is going to have interior angles of 360. Now, I've asked you to memorize that. But you can also use the formula that we used to use. Remember this? N minus 2 times 180, where n is the number of sides. This is how we found the total interior angles. Okay, and if we're talking about a quadrilateral, that would be 4 minus 2 times 180, which is 2 times 180, which is in fact 360. So yes, 360 degrees, if and only if it's a quadrilateral. Those go hand in hand, that's true. So the rest of this about being happy and being outside, obviously this is nonsense. You know, that's a matter of opinion. Lucas, we don't know Lucas. We know anything about Lucas and what he gets in the class. You're a student if and only if you take geometry? No, what if you're in Calc AB? You know, the rest of this is nonsense. The first statement is really the only one. Even, you know, frankly, even if you didn't know this, you didn't remember about the whole quadrilateral being 360, the rest of these are just silly. So you could throw them out just for being silly and still get the right answer. Anyway, the sum of the exterior angles of a convex hexagon. Well, look, exterior angles were always had a sum of 360. All of the different polygons we were looking at were always convex. So convex just means it doesn't have a dent in it. But don't worry about the word convex right now. Focus on exterior angles and the sum. That's going to be 360. It didn't matter if it's a hexagon, pentagon, octagon. It's always 360. So that would have been D. What's the sum of the interior angles of a convex pentagon? Well, you got to know that a pentagon is 5 sides. Alright, pentagon is 5 sides. So remember that what I just told you up there about the n minus 2 times 180? That's how we do it for interior angles. So that's what we'll do. So since the pentagon has 5 sides, then that's 5 minus 2 times 180. Okay, so that's 3 times 180. So what's that? $540. Okay, so that's B. Alright, that just leaves the bonus question. The length of SR is 24. That's a given, so I'm just going to go ahead and make that black. Alright, SR is 24. 24 centimeters. The length of ST is 15. Interesting. ST is 15. We're supposed to find the perimeter, okay? The outer sum of all the sides of this rectangle. Well, in any parallelogram, the diagonals bisect each other. That means that this red dot that I'm about to draw is the midpoint of both segments. So that means if this is 15, then this is 15 over here. Okay? So the key to getting to the sides, well, okay, first of all, you know what, now let me focus on this. The key is looking at the correct triangle. And this is the triangle I want you to focus your eyes on. I want you to focus on the one that goes from here to here, down to here, bam. Let's make it red so you can really see it well. Okay, I want you to focus on this triangle right here. Because, you know, the Pythagorean Theorem is our friend. This is a rectangle, which means this is a 90-degree angle right here. Of course, because of the double 15s, you know that this hypotenuse here is 30. So I should be able to find the length of this side of the triangle no problem. A squared plus b squared equals c squared. So let's do that. So that would be x squared plus 24 squared is equal to 30 squared. So that's going to be x squared plus 576 equals 900. Subtract 576 from both sides. So that's going to leave us with x squared is equal to 324. Take the square root of both sides. $18. Okay, so x is 18. Alright, fine. That means that this side of the triangle, this QR, is 18. Okay, I feel like I should change colors for some reason. So look, now let's just use the symmetry of a rectangle. Opposite sides are congruent. So if this is 18, then this will be 18 over here as well. If this is 24, then this will be 24 up here as well. So now we can just add up all these to get the perimeter. $84. So that, my friends, is why the perimeter is 84. And that's the bonus, man. That's it. We're done.